purpose of this video is to help you learn how to use the spreadsheet for front-end geometry. So I've got an example here because that's the best way to show you how to do it, is just to work through an example. You may want to pause the recording here and write down all of these dimensions, but I've got the dimensions in here for the kingpin, angle, theta k, the h, the g, all of these things that are used in the derivation. And I've got an error here. This one's supposed to be r. So that's the radius of the tire. This s is the distance from the center of the tire over to where the lower wishbone connects. Remember, these two dots here are connected to the chassis. So this dashed line is sort of a connection into the chassis. And the lower wishbone length, L, all these things. This is the spreadsheet that you guys will download, and you're going to change these numbers up here. These are the numbers that change. Where it says calculations below this line, you don't want to mess with anything below that line. Those are just a bunch of internal calculations that it's doing. And then the graph over here shows you how the bump scrub varies with the bump height. So I just plotted it from minus an inch to an inch, and you can see for the one that's in there right now, it's a very low bump scrub. That's how much the tire scrubs back and forth. So in our example, the lower control arm is 13.2. You can see as you change it, everything updates, but we're going to solve for the upper control arm length, because that's the purpose, is to solve for that upper control arm length to zero it. So between the control arms, the H value is 9.4. The kingpin angle is 14 degrees. And you can see internally it's going to compute it in radians too, but just put it in degrees. The distance from the ground up is 8.1 inches in our example. This is 4.1 inches in our example, and the radius of the tire is 12.5 inches in our example. So we go ahead and put those in. This is, Excel used to call this goal seek. Now they call it solver. But we're going to make this number 0 by changing the upper control arm. And this is a feature in Excel. It's sort of like a root finder on your calculator, but it can solve much more complicated problems. So under data, we click on the data tab up here. And this is the solver. As I say, it used to be called goal seek. So we click on the solver. And of course I've already used it, so everything is coming up. But in this objective here, we're going to put cell E8. So you can see this is cell E8, the goal seek cell. And we want to choose a value of 0. And I've got it set up to make it 0. By changing this cell, and so what we're doing is we're using this solver, and it's going to change the value of this cell to make this cell 0, which is what we want to do. And when we get it all ready, we click solve, and you can see it got it very close to 0, minus 5.8 times 10 to the minus 9. And so that's okay. And so by working through this, it has chosen an upper control arm length, or an upper wishbone length, of 6.146 inches. And that's the length of the upper arm that would make the scrub minimal. And this is the bump scrub as a function of bump height, just like we had before, and you can see it came out very nicely here. After we set this, we go to this tab to set the Ackermann and bump steer. And some of the stuff on the first one go to this one. So the steering knuckle offset length, I just used 4.25. We won't really have to change that one. The distance, the Y0 distance, if you look on the first page, it's 1.88. The wheelbase that we're using is 120 inches. and the distance between the two kingpins, the width between the two kingpin axes, we're using 52.5 for this particular example. So we put those all in there. The approximate calculations are done here, and please don't mess with any of those. This is our first estimate for x0, y0, and I've got it set up so that this is the goal seek here, and it's gonna change this value t here to make the goal seek 0. So once again, we go on this, we go to the solver, we want to set it to a value of 0. So we got this is the number we want to set to 0, and we're going to change this cell to make that happen. And then we go in and we run the solve, and it did find a solution. And then this is going to set up your geometry here, and this is how your Ackermann error, steering error is going to vary with kingpin rotation, and this is how your bump steer is going to vary with bump height. And so we've got everything optimized.